mathematicians. I have set up my notebook in order for our lesson today, which is 1.1. We are going to model place value relationships. So the big question we want to answer by the time we're done with today's lesson is, how can you describe the value of a digit? Just to remind you, from third grade, a digit is a numeral from 0 to 9. So in this example, we have a city, Sand City, and the population, or the amount of people that live there, has 338. So Sand City's number or population has 3 digits. I can count them. 1, 2, 3. Each of those digits, though, holds a different value. This 3, well, it's not the same digit as the 8. It also has different value. Just like here, 3 is the same digit as 3, but they hold different values. We're going to learn that this 3 has a greater value than this 3. While we go along, I want you to notice any patterns throughout our math lesson today. So to start off, if you were able to predict that we were going to use a place value chart, then you were correct. From the video you just watched, we learned that there's an important tool, the place value chart, that I'm sure you've seen from third grade or second grade, in order to find the value of our digits. So let's take a look. If we start all the way to the right side, we have the ones place value, and that's represented by one little cube. If we move to the left, we're then going to have tens, which is represented by 10 cubes. Hundreds, there are 100 little cubes in there. Thousands, there's 1,000 cubes in there, and then 10,000s. In this image, there would be 10,000 cubes. So I want you to notice that on my chart, each place value increases by 10 times. That's what that says right there. Times 10. I'll write it here so you can see. So as I move from my ones to my tens, it gets 10 times larger. Same as when I move from my tens to my 100s, 10 times larger. If I move from hundreds to thousands, 10 times, and thousands to 10,000s, 10 times larger. Before we jump into our cities, which are listed up here, our large cities and our small cities, some of these large cities are going to be familiar to you, and these small cities are really little towns in California that just don't contain as many people. So their values are a lot smaller than the populations of the larger cities like Fullerton, Anaheim, and Placentia. So a quick warm up here, we're going to look at our number 30. And we're going to break 30 down, okay? So when we look at our number 30, we can see that we have 2 place values, 1, 2. If we look at our place value chart, we can see that it lands 1, 2. It's landing in the 10 spot, our 3 is, and we have a 0 in the 1 spot. So what does that mean? We have 0 ones, but we have 3 tens, or 3 groups of tens. So if I were to write, how many tens do I have? Well, we see that there's going to be 3 groups. If we were to break those 3 groups down, so for example, let's say, do it in pencil here, that we had 3 tens. I'm going to draw them into our place value chart. And I wanted to break all of those down into ones. We'd split this group of 10 into ones, that'd be 10. Another group of 10 into ones, that'd be another 10. And our final group of 10 into ones, that'd be another 10. So technically, we would have how many ones? Well, we'd have 30 ones. 3 tens is the same thing as 30 ones. We can just represent it differently. Okay. Let's pull one of our city populations. So I'm going to choose Sand City, where they have 338 people in that city. That is their population. 338. Now, instead of, like over here, I looked at the 3. I think I'll look at both of these 3's because there's actually 2, but they're going to have different values because they're in different place value spots. So let's look at the one that I circled or put a rectangle around in purple. So this 3, I can count, okay, 1 spot, 10 spot, just like here. We have our 1's place value, our 10's. So in this example, I again, just like I drew before, I have 3 of them, 3 10's. So what does that mean? Well, just like over here, just like this 3 is, it's going to mean the same thing, 3 10's. If we were to chop up those 3 10's and convert them into 1's, I'd have 30 1's. And here's where that value changes. Let's take a look at this 3. This 3 is not in the 1's place value. It's not in the 10's place value. It's in the next place value, which would be 1's, 10's. It's in the 100's place value. So this 3 is saying we have 3 hundreds. If I were to draw it in my place value chart, I would draw 3 of these. There's 100, there is 100, and there is 100. Imagine that all those little lines are in there, and it's creating hundreds of little cubes. So I can say that this 3 represents 300. If I were to write it in word form, 300s. And there are 338. So here's where we get our 30, here's where we get our 300, and then of course our 8 just represents the 1's place value for 8 single 1's. So mathematicians, now we're going to look at some cities from our chart from up above. Now I started with the smaller cities. So we have San Ardo with 517 people and Alto with 711 people. Now I see a digit that is similar in both of these numbers. The digit 7 falls in both San Ardo and Alto. Now the difference is if we look at San Ardo first and we see that this 7 falls in that first place value, which is our 1's place value. So we can say that in this 7 holds the value of 7 1's. Okay, in Alto, the 7 falls in the 1, 2, 3 third place value. So if we check our chart, 1, 2, 3, it's going to fall in the hundreds place value. So I can say that this 7 holds a value of 700, or I can say that there are 7 hundreds, which is the same as 700. Now, if we're going to fill in our sentence here, we're going to take a look at which one's bigger. Well, let's think, 517 or 711? 711 is definitely bigger. So keep that in mind when we read our sentence frame here. The value of the 7 in the blank is blank times bigger than the value of the 7 in the other one. So if we're talking about the one that's bigger, we're going to talk about Alto first with 711. So the value of the 7 in the, what place value do we say that is? In the hundreds is blank times bigger than the value of the 7 in the, we said in San Ardo, the 7 fell in the 1's place value. But now we have to fill in our blank here. How do we know how many times bigger? Well, if I look at my place value chart, I can see that I have hundreds and 1's. So here's my 1's, here's my hundreds. Let's see how many place values we shift. We go from 1's over, so that's 1 times 10, but we're in the 10's now. We're not in the hundreds yet. So we need to go one more time over. So if we go 10 times and another 10 times, 10 times 10 is 100, right? We know that our 1 and our 1 times 1 is 1, and we add our zeros, it's 100 times the value of this 7. So again, although the 7s are the same digit, they're both 7s, since they fall in a different place value, they hold different values, which means they contribute to their overall number in a different way. This one contributes with just 7 ones. This 7 contributes